So by now we have a really nice representation of our cart class. We've talked about hidden or private data structures. We've looked at setters and getters with our value properties. We've talked about immutability. However, there is one thing that we've kind of missed. If we do scroll down to our hot dog on line 26, this doesn't really feel that object oriented. So in this lesson, we're going to show you a bit more object-oriented programming concepts and introduce the concept of inheritance. Now, we kind of know what inheritance is because we've talked about this proto-object, but the whole idea behind object-oriented programming is to allow us to compose objects or create new objects from existing ones. If you're perhaps coming from a TypeScript background or another programming language, we have this concept of an abstract class. Now, an abstract class doesn't necessarily get called directly, but its sole purpose is to be inherited from. So if you have used abstract classes in something like TypeScript or another language, we can also apply this principle to our code here. Now, what we're going to do in our hot dog is just completely eradicate it. However, we're going to build out some new classes around our cart class. Now, this is called code folding. You can see this little arrow here. So I can actually just hide out my cart class to give us a better representation of what's going on. Now, what we're going to do alongside our cart class, and you can imagine that in a real world application, these are distributed across a few different files. So ideally, we don't want to keep everything in just one file. It's going to get messy. It's going to be hard to maintain. So use your imports, use your exports sensibly. And this is where we would typically export a class and import it and then create some products with it. So what we're in fact going to do, because we have created our class of cart here, and then we've instantiated a new instance of it, we're going to build a new class called the product class. So here we're going to go and create a product. Now, because we want some properties, we're going to say we want an ID. We're going to give it a name. We're going to give it a price. We know by now that we should expect some kind of constructor function. And all this is going to do is be responsible of setting the ID, the name, and the price to those internal variables. So here, let's go and hook things up. We'll do ID, name, and price. And then inside the body of the constructor function, we can, you guessed it, this ID equals ID, this.name equals the name, and finally this.price equals price. So what this is in fact doing is creating a base definition for our product. And you can see that we have an ID, a name, and a price. ID, name, and price. So you can see what's happening. We're going to change this over to a more object-oriented, this idea of encapsulation, where we have behaviors, we have constructors. This is what object-oriented programming is all about. And as you progress through your JavaScript career, you'll notice that you can, in fact, mix the two flavors. You might have a functional programming application or a library that you then use in an object-oriented context. Or perhaps you have some functional programming that uses an object-oriented style. Ideally, we would kind of use the same approach. However, it does, because it is JavaScript after all, it does allow us to use whatever we want at any point in time. So most of these advanced concepts are about learning the patterns and being disciplined enough to compose, write, and stick to the same pattern of code and adopt these good practices, which is what this course is all about. Now, one thing I'm going to do is add a get display name. And the idea of this is we're going to show you how we want to then split out our JavaScript to then start inheriting from this class of product when it gets a bit more complicated. So first off, we're going to return an ES6 string literal. And inside of that, we're just going to interpolate our ID. So we can say this.id. And all this is just going to show the actual emoji next to the name. So here we can then go and say this.name. So anytime we reference this .display name, be aware that it is a getter. We're then going to take the ID and the name and just return it as a string. So this will give us a nice image in the browser if we were to go and render things out. We're not going to do that, however, it does give us the capability. And when we start inheriting things momentarily, this will come into more effect then. So instead of having our const hot dog, which we then say equals a new object literal, we're in fact going to say new product. We can then pass in the ID, which we're going to use as an emoji, followed by the price. So you can see that we can start omitting these names of the object properties, and we can just simply pass them into our product constructor function. So we have the ID, the name, and the price. So if you take a look over here, when we save this out, we now have something different. We don't just have an array with an object and ... inside. We actually have an array with a product. So you can see that object-oriented programming is quite nice. It gives us the class name alongside the object that we actually have. So if we were to expand this further and perhaps have different types of products, we might want to be a bit more specific. Now, what I'm going to do is duplicate this because I want to create another object from our product. And I'm going to create a burger instead. So let's go ahead and find that burger emoji. You can call this whatever you like. I'm going to call this the super burger, and we'll give it a price of $4.49. We could then, for example, go and add this to cart. We can say cart.add and then pass in that burger, save things out. And of course, all of our setters, the getters, are creating these immutable objects under the scenes. So when we log things out, we have a nice immutable data structure array full of our products. So this feels really nice. Now here comes a common problem that we tend to deal with in object-oriented programming. Now let's assume that we have a hot dog, we have a burger. What I'm now going to do is allow the user to potentially change some options. So we're going to say that this comes with mustard, and our burger is also going to come with a few options as well. We'll keep it nice and simple. We can just say that we're going to have some bacon in this one, and we'll also have some pickles. So after we've done that, what we need to do is add this to the constructor, and I'm going to call this the extras. So if you want to go ahead and say extras. Now, if we don't have any extras and we don't want to really initialize it, we can initialize it with an empty extras array so as to give the user the choice. Now, we also want to initialize our extras property. I'm just going to leave this as undefined. And down here, we can say this.extras equals any extras that we might want to have. We can then look at our data structures and we have this extra, which is just a nice string array with 2 items in. This is all great, apart from when it comes to expansion. And what do we mean by expansion? So let's say we start off with hot dogs and burgers, but we want to now add some drinks. So what we would typically do is something like this, and we could say const. We're going to call this the small drink. We're going to say new product. I'm going to take our burger emoji and we can replace this with a different emoji and also give the drink a name. Here we just call it the big slurp. I'm going to give it a price of $1.99. Now the difficult piece comes when we have a new requirement where we don't want to add bacon and pickle to a drink, but we're still using this product class. Now, I don't know about you, but because we're creating a small drink, it might be a nice idea to define the size of the drink. So here we're going to say small, and we could then do something like this. So what I'm going to change this to is the medium drink, and we can then go and add this as medium, and we can go and replace our small with a large drink. So now we've got the same drink, which comes in different sizes, but we also have 2 separate food items, which then have different optional extras. So this seems quite logical, and I think this is pretty much what you'll see if you were to order something like this. You get a choice of drink sizes, and you can modify your order. Now the problem is that we have an array here of extras, and we just have a string of the size. So what could we do? Now it probably makes sense for us to quickly add these to the cart, so we can take a look at them internally. And what we're going to look at is our console log. So first off, we'll save this out. We can see that we have each individual items. Now in a real application, the ID probably will be something unique. It doesn't really matter for all intents and purposes for this demo. But you can see here on our drink is we have an extras property called large. Now we could just roll with this. We could go into here and say if the type of extras is an array, then we could assume, because we're trying to use an array here, that we're trying to add some extras. But if it's a string only, not an array, then we could assume that we want to declare a size. Now, I don't know about you, but that's how I used to code, and it doesn't feel right nowadays. So what we're going to do is use this concept of an abstract class, which product is about to become our abstract class. And we're going to then learn how to inherit some of these properties and look at how they apply to a different class in an object-oriented fashion. So what we're going to do underneath is create a new class. Now, instead of product, we're going to call this food. The only difference really when we look at it is that our product has the ID, it has the name, and it has the price. And it also has this extras. So what we're going to do is in fact just eradicate this extras entirely and move it down into our food constructor. So let's go ahead and just paste this first piece in. We obviously need to add our extras property to declare it on our class, which means that we can eradicate it from here and also remove it from the function arguments here. Now, before we remove it entirely, I'm going to copy all of these function arguments because we want to use them again, and we'll simply leave ID, name, and price. We'll do this because we want to paste the exact same items into our constructor for our food, and then what we're in fact going to do is inherit by using this extends keyword from our product. Now, all this is going to do is take all the properties and the object from our class of product and simply extend it, which means it's going to merge those properties into a new object called food. Now, the way that we can get this working is by calling super. So what this super is in fact doing is invoking this class essentially from inside of this class. And we do this to essentially merge all the properties from our product and complete that extension onto food. What it does mean is that we need to take ID, name, and price and pass those into the super, because remember, this super is basically product. So when we do super, you're essentially doing new product in here. That's what it can feel like. So don't overcomplicate it. That's all that super does. It allows us to invoke our base class of product and pass those ID, name, and price properties all the way through to the constructor. Now, I deliberately added this getter of display name because anything that you add here is going to be available on our food class. So let's take this and go and replace our products. So at the moment, we have added our hot dog, our burger. So we have two food classes that have been added. And we also have added our drink. So we've got 3 drinks, which are still of type of product. So in fact, this fourth argument here, this fourth parameter of the drink's size is going to be completely ignored at the moment because it doesn't exist on our product anymore. But that's absolutely fine, and we'll refactor this momentarily. So the nice thing when we hit save is we can now start to see the different types of objects that we're composing and creating. And if I expand these, you can see that we have things such as display name, we have the price, the name, and I think you'll be glad to learn about all these proto underscore proto objects, because look, we have underscore proto, which points to our product. So this completes the entire circle for this chapter. And I think we've come a long way to understanding JavaScript in immense detail. And this is pretty much all you need to know in terms of object-oriented programming to maximize the benefits the language can give you. There isn't really much more to JavaScript than this. It's plainly how you use it. And this chapter is all about giving you the tools to maximize your JavaScript skills. So this food item is a class. We've used this base class of product. We've not included it directly. We've not called it directly. However, we are still with our product. So it might make sense to do something like this, where we call a new drink, and then we can modify that last argument. Now, the idea of doing this is because we want to create multiple products, but we know that the food is different to a drink. So what we'll do is underneath create a class called drink. Again, we want to extend that product that we've just created. Now, these are going to look pretty similar, apart from extras is now going to be called size. We can then pass in our constructor, which takes the ID, the name, the price, and also the size, which means that inside the body of the function, we can call our superclass, pass off the ID, the name, and the price, and then underneath we can say this.size equals the size. So we're only using this as a slight wrapper essentially just to get access to that underlying product class that we're just simply inheriting from. So let's check this out. We have our food, we have our drink. One has a size property, the other has an extras property. When we talked about potentially looking in the constructor and we said, oh, we could check if it's an array or a string, and if it's an array, it's an extra, and if it's a string, it's a size. We don't need to do that anymore. We don't care about that. We could just actually say, if my object has a size property, then we know it's a drink. Or you could even add some properties that actually tell you that it is of type drink. We also get the full benefit when we save things out. You can see that we have food, food, drink, drink, drink. So this is really nice, and it tells us the type of our data structures. Now, what's also really nice is the ability to use the instance of keyword, and this is also something that creeps up in Angular as well. If, for example, using the router, you have these different routing events, the start and end, and the way that we would do things is typically checking via the instance of. So we could say, is my hot dog an instance of food? Let's save this out and see what it gives us. So this is interesting. We have our true statement. So hot dog, which is up here, is a new instance of our food. But what's also really interesting is the hot dog an instance of our product? We can save this out and we have true. So that's yes. Now this is what we call the prototype chain. If we were to have a look inside our cart's value, you can see that we have all these individual objects. Now the prototype chain means what is the next link in the chain. So if we go up a level, essentially I want to say what is the creator of me? What is the next level up, which is the product, which is why the instance of returns true when we say is our hot dog, which is of type new food, is it an instance of the product? Because yes, it is, because we are calling our super and super inside our essential subclasses they are. Now, I mentioned at the beginning that we have TypeScript where we have this ability to define something as an abstract class. Now, this is red and underlined because this does not exist in JavaScript. As you can see, the abstract modifier can only be used in TypeScript files. So what that would allow us to do is not call new product directly. So that is what abstract does. And this also gives you another benefit of using TypeScript, for example, because it doesn't stop us as developers actually invoking a new instance of product. So it then comes down to, oh, we need some documentation to say, don't use this directly. You want to go and use the food, which then extends the product. So you can see why TypeScript's quite nice here. Now, the moral of our story was that instance of uses the prototype chain, or it looks up the prototype chain. So what it's essentially going to say is my hot dog deriving from my food class, which we know it is because we can see it here. But then we can say, does it also derive from my product class? And it will then look up the next layer of the chain. So this one is going to look at the first layer of the chain, this food item, and then this product is going to look up the prototype chain as well. So both of these are looking up the prototypes to see where the objects came from. So you can see how by understanding this in far more detail, this is going to really help us by not introducing bugs and following clean patterns for coding. So that's it for this video. The idea here is that when our applications grow and scale, things become more difficult to manage, which is when we start to break out things into further classes, and we can use inheritance via the extends keyword with ES2015 classes. We learned about how to call super, which is essentially passing those details down to our product class so the constructor can wire things up cleverly. We've also looked at using a getter as an example, which would, if called, return us the display name. So you can see all of the display names on each individual item as well. So this is really nice. This gives us a nice idea of how to handle inheritance with JavaScript. Years ago, this became a lot more cumbersome and more difficult, and we would have to use the .call methods to invoke what is essentially a parent class. Now in ES2015, we have this really nice and clean extends keyword, and if you've come from other languages, you'll also be used to that as well. We've talked about some of the challenges of growing a code base. This is just a really simple example, but it does definitely demonstrate the need for some solid refactoring and consideration when creating our classes in an object-oriented programming setting. So that's it for this lesson. I hope you've really enjoyed this chapter and learned an incredible amount of things about object-oriented programming in JavaScript to strengthen not only your skills, but your advanced knowledge of JavaScript.